Today we will be running this Python code completely, okay? I specially have written this code so that we can run this today. Now you have to tell me what each line is doing, guys. First three lines are we are importing our NumPy, Pandas and Matplotlib. And in sklearn, as I told, you will have the machine learning algorithms. It also has the data sets as well. Instead of importing the data set as a CSV file, I'm just directly taking the data set from sklearn itself. So now let's say that I'm running this 5 lines. Let's say that I'm running this. Okay. Okay, it's saying that we have to end this somewhere, triple quotes, because we are commenting it, right? Great. So what I have done here is I've imported the iris. Iris is one of the famous data sets which people generally use it for practicing. You can also use it if you want. So now let's print this iris data set. But before printing, you can also check how does the directory looks like for iris data set. Okay, or also you can print it if you want. So it says that this iris data set has lot of things. It has some DSCR, you can look into that. It has data which we require, okay? And then feature names, the feature names are the sense, these are the columns, okay? Column names. It has file names which are not required for our analysis. It has target and target names. And target names are required for us, okay? Because target names are our outputs, right? So it has some inputs and then it has some output. So let's see how does our input look like. What is the 7th line of code doing? It will tell what kind of data set it is. So if you remember, when you import any CSV file using Pandas, it will tell you that is a data frame. But here it is showing the type is as a sklearn bunch. This has different data frames. As it is a bunch, it has different data frames. But what is required for us is data which has our input features and the target names which has our output features. Okay. Okay, now let's look at the next line. How does it work? Let's create a data set now using Pandas. From this data set iris, I'm just taking data and the column names are iris.feature names because this has the feature names. Now let's look at this and you will understand what I'm trying to tell. Let's print this because until and unless I print this, it will not be printed, right? So what you can do, you can always print few things and then you can understand what is it. Now, if you notice, this is our serial numbers. This is not required though. It will just be printed. Don't worry. These are the sepal length, sepal width, petal length and petal width. What we are trying to do here, by looking the feature names, you can understand that we are trying to classify the flowers based on the sepal length, sepal width, petal length and petal width. So these are our inputs, 4 inputs, right? These are our 4 inputs. Now, let's create a column. These are the 4 columns. Now let's create a 5th column, target, which will take this target. Okay. Now let's print that also. Let's print our target also. Now, if you notice, I have a new column target which tells 0, 2, 3, something, something. There are a lot of data in between 0, 2 or something. But the challenge is I am not able to understand what are these 0 to mean, right? I'm not able to understand. See, these four I know. Sepal length will be in centimeters or meters, let's say. That's a length dimension. This is sepal width. We know the dimension of width. It should be number. Petal length, petal width. But what is this 0, 1, 2? Where are the names corresponding to this 0, 1, 2? Which are our targets, right? So for that, what we have to do, we can print the target names also. If you want to understand, we can print the target names as well. See, Setosa, Veriscler, versicolor and virginica. So 0 represents Setosa, versicolor is 1, virginica is 2. So now we have a kind of bunch, a sklearn bunch, as we have already seen, by name Iris, which has different datas. And for our analysis, we are using data, target and target name. Data has all the input features. Target has all the target outputs in terms of numbers. But how to know what are those numbers corresponds to? It's there in target names. Okay. So far so good. Any doubt, guys? Till line number 14, do you have any doubt? And you can also do this, guys. If you want, you can try this also. Describe thing. I'm not sure if it's gonna work, but let's see. So what is it is doing? Our data frame is df. So I'm running df. Now df has sepal length, sepal width, petal length, petal width, and the target. So it will tell you the count, the number of records at one shot. It will tell you the mean. It will tell you the standard deviation. It will tell you the minimum value, maximum value, and 25 percentile, 50 percentile, and 75 percentile. Achha, by the way, before going ahead, can you tell me, I know that you all know what is count, what is mean, standard deviation, and min and max. What are the 25%, 50%, and 75%? Let's say that you have a data or the numbers, some simple numbers. Then you know what is the min value, which is 0. Max value, which is 100, right? And then you know what is mean here. Mean is 50. What is median here? Median is also 50. You can calculate it, guys, if you want later on. And then what does median do? And what is the count? 101. So what is a median? Median is a middlemost number which divides the data set into 2. So 50 would be somewhere here. Now this min is also called as Q0, quartile 0. Max is called as quartile 4. So what we are doing is we are trying to divide the data into 4 parts. Okay. And then median would be Q2. So there would be now let's consider this as one series, and then there would be median for this also, that is called as Q1. And then this is as a second series from 50 to 100, and there will be median for this series also, that is called as Q3. So 25th, 1/4 quartile, 1/2 quartile is median, and then 3/4 quartile is Q3, and Q4 is maximum number. So these are the 50 is the median, right? So these are the quartile values. Okay, let's run this line now. And I believe you know what is this. From sklearn, we are importing model selection, and from model selection we are importing this function train underscore test underscore split. And then what I am doing is I'm giving all those 4 features in X. Okay, and then the target is in Y. Okay, so let's do that first. Okay, let's do that. Okay, great. Now we know what is X and what is Y. Now if you want, you can print X again and Y again if you want. But then I'm not doing any exploratory data analysis here, guys. You have to do it. Okay, try to understand the data, try to plot different graphs. Okay, so this is how your X looks like, and then Y also you can print if you want. Now what I'm doing here, I'm splitting the data with respect to 70-30 or 80-20, guys. 70-30 or 80-20, right? So now I'm dividing the data, right? And then let's print it. So what I'm doing here, let's say that I have a 150 data sets. I have a data set with 150 records, right? So if I print the length of X test, what could be the length? What could be the length, guys? Can you please tell me? You know what this len function is doing, right? Len is the counting the number of records in that particular data set. So as it is 80-20, 80% would be in X train, 20% would be in X test. Similarly, 80% would be in Y train, 80% would be in Y test. So out of 150 data, if 20% is going in test, that means 30, right? So you're right. 30 records will be in X test. 120 records will be in X train. Let's run this. So as you are right, X test has 30 records and X train has a 120 records. And X has 4 features: sepal length, sepal width, petal length, petal width. And Y has a feature target. Now similarly, this is again that 1 or 2 lines of code which I always talk about. One function from sklearn we are importing SVM. Okay, and then from SVM we are using SVC as a function for support vector machines. So if you remember, we had empty, there were empty, for example, for linear model, if you remember, we have given some, if you remember for linear regression, what we have done, linear model dot linear regression, and then we had empty parentheses, that means no arguments. But in random forest, if you remember, we have given n estimators, right? Similarly, for support vector machines, we have to tell what kind of kernel we are using, what kind of gamma we are using, and then what is the C value. So yes, you have to tell me in tomorrow's session what is the C value and gamma. I've given you some basics of kernel. There are polynomial kernel, there are linear kernel, there are different types of kernel. Similarly, gamma also helps us in, you know what is this kernel doing, right? Transformations. It helps us in transformations to come up with a better hyperplane. How does this gamma and C value helps? Please let me know by tomorrow, okay? So now let's run this model, and then if I run this model, you'll not be able to see anything because that's a training model which is stored in variable model, right? Now if I say print model also, let's say I'm printing model. What you will see is just that how this model is built on. It is built on support vector machine with C value equal to 1. Cache size, these are all irrelevant for us. Kernel linear, you can try different kernels. Okay, so this is what it is giving, but we have to fit the model on our training data set, right? So let's fit it on our training data set. Now we have fitted the model on the training data set. It's printing the same thing again. Okay. Now we have to predict the score for our output for our test data set. So what is this 0.9966? This is our accuracy. So if you want to print how to predict the values, guys, let's use this. So what I'm doing, I have 30 data records, right, in our test. So you will see that there are 30 values here. Okay, 2 means Virginica, 0 means Setosa, and 1 means versicolor. So these are the predicted values. How about the real values that we already have in test, right? So this is our predicted value, and these are our test values. 2, if you notice, 2, 0, 2, 2, 1, 1, 2, same values we are getting here. Now you must be wondering what are this, right? On the left side, for our Y test, there are some values on the left side also, 128, 18, 130. What would be those values? Record number, exactly. Those are the observation numbers because we are doing sampling, simple random sampling. It will take any random samples. So if you notice 2 and 2, 0 and 0. So out of 30, if you understand, out of 30, the accuracy is 0.9666 something. 0.04 or 0.033 is the missing accuracy, right? Serial numbers. So we are not able to achieve 100%, we are able to achieve 0.966, right? So can you tell me out of 30, if the accuracy is 0.966, for how many records our classification is working properly out of 30? 29, right? Because the missing accuracy is 0.033. So there is one record which is not matching. The predicted value is not same as actual values. And how do we do that? If you remember in decision trees, where is that decision tree? So let's use this from decision tree. Let's use this and copy it in our SVM. Because as I told, I don't remember the syntaxes. So let's use y predict is equal to model.predict, which is same as this. So let me remove this. And then from sklearn, I'm importing matrix. So what is this matrix has? Matrix has a confusion underscore matrix as a function. For us, it will come up with a y test and y predicted values, and it will be stored in CM. And then we can print CM. Okay, so you can print the CM. CM is a variable, so these are all not required. So now if you notice, this is our confusion matrix. So if suppose the actuals are, let me draw this. Let's remember this table and then analyze it. So our table was something like this: 16, 4, 9, 0, 0, 0, 0, 0, 1. This is what we have, right? Exactly. Now let's say that this is our actual values, this is our predicted values, and these are 0, 1, 2. This is 0, 1, 2. So zeros are setosas, right? So setosa is predicted correctly. We had 16 setosas as our output, and it is predicted correctly. Similarly, if you notice, there is no setosa which is in actual but predicted as some other versicolor or virginica. So it is done. Setosa is correct. Now, versicolor. We had 4 versicolors in actual, okay, and it is predicted also 4. So that's correct. Now going to virginica, if you notice, we had 10 virginicas, flowers, but then out of that 9 are correctly predicted, but 1 is incorrectly predicted, right? So that is where we are losing the accuracy. Okay, so that's the important thing. Now you must be thinking we are not able to visualize it in a better way. So how we can visualize it in a better way? So what we can do, I can quickly do a better visualization thing, which you will learn by experience. There is a library by name Seaborn. See, I know that I didn't tell about this library in the initial sessions because it is not important for our analysis. It's important for visualization. Okay. So Seaborn has a library and I'm aliasing that as SN, like we do for NumPy as NP. And then I'm just plotting a graph with a figure size of 10 by 7. You can draw 10 by 8. The bigger the size, the bigger graph you will look in. And then in Seaborn, SN, there is a function by name heat map. In that function, we are allocating this variable CM in which we have confusion matrix. And then annotation equal to true. That means we want to see the annotation, right? Otherwise, we will be confused what is there in x-axis and what is there in y-axis. So we are plotting x as prediction and y as actuals. Now let's run this. And this is the one which tells if I don't do this, no, the plot will not be appeared. If you want to check, you can check it. The plot will not be appeared until unless I uncomment this. So now there is a plot which is coming in. Now if you understand, This looks so better. Let me bring the chat box. Yeah, this looks so good, right? The previous small table was looking good, or this one is looking good, guys? These are the actual values. These are the predicted values. Actuals 0, predicted zeros, same. So there are no false values, or there are no incorrect classifications. Similarly, actuals ones are 4, predicted ones are 4s. Actual 2s are, so actual 2s are 9, predicted are 9, but for 1, there were actual ones which were 5, but predicted were only 4. So when you now understand, when we have done the analysis by looking at only the small table, we have done that one mistake, right? So the table what we were seeing there was not this, it was something like this. This was predicted and this were actuals. Okay, so how nicely when we do a visualization in a better way, we can understand things in a better way, right? So did you understand this confusion matrix or this classifier table? It's so easy to understand now. See, from that small table, I have also committed a mistake, right? We can also commit mistake by looking at that small table because we were not having any labels. Now by this, we can understand in a very easy way. And then this is just a color graph. So higher the numbers, it will different colors. That's it. It's okay. But then you understood, right? This is only misclassification, which is in one number. That's the reason we have an accuracy of 0.966. Now, let's say that I have a 30% test data. Let's do not plot the graph. Let's see what could be the accuracy for us. Okay. We are not able to see that cursor here because it is still open. So we have to close this and then only the Python will appear again, and then let's run it again. So now if you see again, what is the result which you are getting accuracy as? Again, there is one misclassification, guys. Again, there is one misclassification, but the accuracy is slightly increased from 0.9666 to 0.977. How? This is mathematics. There was one misclassification, right? Previously and now again. Then how come the accuracy is increased? Can you tell me, guys? Exactly. So previously we had 29 correct classification divided by total 30 data sets in a test sample. Now we have 44 divided by 45. So the accuracy has increased because the numbers are different, right? So now let's try with 0.1. So with 0.1 also, if you notice, this one thing which is not able to correctly classify. Now you can check which is a record which is incorrectly classified, and then you can try to understand that particular record, what are those values and why it is not correctly getting classified. You can go deeper, dig the holes, and then try to understand what's wrong with that one record. Then you will understand that one record, the input feature values what are there for that record are incorrect values. So you don't have to worry about that. It's just an error. So while recording those values, what they have understood is how to pick that record. What you have to do is you have to make a table of y test and y predict. Okay, create a data frame, or you can create a data frame of y test and y predict. Now you have y test, you have y predict, right? Create a data frame out of it side by side. So you will be seeing the numbers 220022, and one record will be not correctly classified. You can take that one record and then you can try to do the deeper analysis if you want, but it's okay if you don't want to do it, but you can always do that so that you can tell to your client that the actual value what you are writing. For example, here, where is that? Let's plot this. The actual value is given as versicolor, okay, but it is not versicolor, it is virginica. So you can ask your client that the table, the data what we have, it's slightly incorrect. If you want to have a better predictions in future, you can change that output, or if you want, you can tell them try to do the experiment one more time and then come up with the actual output for that particular record. Instead of doing the experiment for all the records, you can do it for that particular record which is incorrectly classified. Okay, so you can try different things, guys. I would say please play around with the Python. It's very important. Okay, please keep playing around with the Python so that you can do various things. And then if you want, you can change the kernel also here. As I told, you can use polylinear or like polynomial kernel or anything. So you can do various things. So please try it, guys, I would say. But I would not consider any assignments as correct assignment until unless you do exploratory data analysis. I want you guys to do exploratory data analysis, finding mean, understanding the data, plotting the graphs, try to look at the graph. And then when you submit the assignment, you can write, for example, if I'm calculating the mean, and then below that you can write in the comments, by looking at the mean value, I've understood this, that this feature is influencing more to the output or something like that. By plotting the graph, I have understood this. So maybe the one record which is incorrectly getting classified, you can capture this record at exploratory data analysis itself. You can do that if you do a lot of exploratory data analysis. So I always tell my students, try to eat the data. When you eat the data, then only you can understand the data in a better way and then digest it. Okay, so that's how first step, try to understand the data using descriptive analytics, and then understand why we are doing this, why we are working on this problem, that is diagnostic analytics. And then using predictive analytics, we are doing the predictions. And then prescriptive analytics is recommending something to your client. So whenever there is a new, in future, there is a new sepal length, sepal width, petal width comes in, you can always tell this could be the prediction with 96.67% accuracy. Okay, so that was all from today's session, guys. Tomorrow we will be looking one more classifier, which is KNN. Right. If you can come up with an example of kurtosis in tomorrow's session, it would be useful. If you try to do your homework at the back end, that would be useful. Otherwise, if you're not able to come up with any example, then tomorrow I will only provide the example for kurtosis and then tell you how does this kurtosis be helpful in tomorrow's session. Thank you. And please work on the puzzle. Tomorrow I'll be asking the answer for that. Okay, thank you, guys.